Looked a little bit how to save data. This is what I usually use. I write save, open parentheses, the name of the file I want to save in, and then which variables I want to do. How to load data, it's very similar. So load and then the name of the file. Here's something weird happened, I don't know what. And okay, first of all, I have some corrections to do. You saw last time I got in trouble with a couple of slides. Sorry for the mess. Here's the cleanup. First of all, we showed you this. So x equals a vector with 4 numbers. And then I said, well, you can index the second and the fourth element, so number 4 and number 2, by using this 0, 1, 0, 1 as square brackets. But this is wrong. What actually happens is that it gives you an error if you try out a Matlab. And what we wanted to show was this. Basically, if you convert this to a logical vector, then you can use it to index x. And then I invite you to try this out later on. We also showed you this. So x smaller than 3 is 0, 1, 0, 1. Well, you can see by yourself that it's not true because 1, for example, is smaller than 3. And 2 is also smaller than 3. So what should come out is 1, 0, 0, 1. Yeah? You understand this? X is 1, 4, 3, 2. And x1 is smaller than 3. And x4 is smaller than 3. You can use, so this was different, you can use a logical index, similar as here, to index elements of x and extract them. So if I want to get the numbers of x, which are the positions of x, no, exactly, so now I'm getting messed up again, because I'm looking at the wrong thing. So if I want to extract the elements of x, which is smaller than 3, we said you would get 4 and 2, and of course this is wrong. What is correct is 1 and 2. These are the numbers of x which are smaller than 3. And same thing here. If you want to get the number of x which are smaller than 4 and bigger than 1, well, I get the wrong answer. It's not 4 and 3, it's obviously 3 and 2. This is very simple, okay? I don't think it's complicated to understand. One more thing, you can use find of x to get all the non-zero values. So if x contains zeros, you get only the numbers which are not 0. This was correct. However, if you use find of x smaller than 2, we give you the wrong answer. It's not 2 and 5, it should be 1, 2, 3, 5, okay? Because, and I think it was you who pointed this out, 0, for example, is also smaller than 2, of course. So this is just to, because yesterday was confusion, first of all I was confused, maybe you too. So this is to set this straight. Then there was again from you a very good question. When you use the function core, and we got both the matrix of correlations and the matrix of p-values, well, it was kind of strange that in the diagonal of the matrix of p-values we have 1s. Why? Because here you get the correlation values which are perfect because it's one thing correlated with itself. So the p-value should be 0, not 1. Well, so it took me a while, but I found out if you do this, for example, you put the same column of x, which is 10 rows long, twice. You correlate with itself. Now you get obviously a perfect correlation, and now all of a sudden the p-value is 0 as it should be. So looking around, the help of core doesn't provide the answer for why there's 1s in here. However, there's a very similar function which is core coef, and you can look it up why it's similar. And if you look into the help of core coef, it tells you that P is symmetric, as it is the same size of R, and the diagonal entries are all 1s. And the off-diagonal entries are the p-values for each variable pair. Also looked it up in the internet, there's several people with the same question. And the conclusion is basically, it should be zeros or NONs, just disregard the diagonal ones. So that's the response to that. Finally, there was another question. Yeah?
Related to what you showed before, where the errors were before this. The logical. What is related? Okay, related to yesterday's exercise. So imagine I have a vector with people's weights.
Yeah.
And I want to get a new vector of those people whose weight is above 70 kilos.
Yeah.
What do I have to do if I want the new vector to give me just the values? What do I have to do if I want the vector to tell me the indexes of those values in the old vector? And what do I have to do in order to get a new vector containing zeros and one telling me this is above, this is not above?
Let's see if I can do this in real time in Matlab. Yeah. So, weights equals 1 to 100. Then weights above, say, 50 gives me the indices of those that are above 50. So it put it into ANS, which is
zeros and ones.
Which is zeros and yeah. So that means the ones is where they are above 50.
Okay.
And if I say Tiziano equals, whatever, let's say call them heavy, equals weights over 50. Heavy. Yeah. Heavy gives me the numbers, so extracts the numbers that are above 50.
Okay, these are the values.
Yeah. Is that your question?
They're indexes.
What are the
We're supposed to use find.
Yeah.
Here the values and indexes are the same.
Find weights above 50.
Yeah, which will be the same too.
Yeah, in this case they're the same.
But I suppose the second one is for the indexes.
Yeah.
Okay.
So I should have taken other numbers, otherwise it's not clear enough. Well, I can flip weights. So now weights goes, no, that's not what I wanted, sorry. I still like that. Weights is 100. Okay. Yes. So I changed weights so that it goes from 100 to 1. And
Okay, find will give me the indexes.
the indexes are now 1 to 50.
Thank you.
Okay? Push me my thing here. So there was one more thing I wanted to, or two more things. So there was one question about our t-test and one way to know about the same thing, and I said I'm 90% sure, and so I went to check. By the way, here is an online book which seems to be pretty handy, Engineering Statistics, and they say that under this link, I and basically extracted the essence of it. They say one factor nova is a generalization of the true sample t-test. So this is the same thing. And then I also said, why don't you guys try it out? So here, I loaded exam grades, which you should have. If you don't have it, I sent you the data. And then I did a t-test, I did an ANOVA, and I got the p-value of the t-test, which is 0.9805, and the p-value of the ANOVA, which is 0.9867. So not exactly the same. I don't know, maybe it's some rounding, but you know, it only changes after the second number after the point, the dot. So the answer is yes, it is the same. Confidence interval, I don't know what I said about it yesterday, but it didn't sound too right to me. So again, in the same book you can find definition, and there's actually a book called Understanding the New Statistics, and it's too small to read now, but the subtitle is something like confidence intervals, and etc. So it's a guy saying that we shouldn't be looking so much at p-values and more at confidence intervals. So what is the confidence interval? You might know this, but just as a little refreshing reminder. So how well does the sample statistic, for example, the mean, estimate the underlying population statistics? So if we take a sample like you guys, and I do an exam of how much you know Matlab, and I get a mean, say you know 80 out of 100. How much does this represent the population of first-year PhD students in CISA? And let's say your first-year PhD students. Well, it could represent it well or not. So the confidence interval sort of provides a range of values which are likely to contain the population parameter of interest. In this case, the mean of this test, of this exam, in the sample. In this population, which is the PhD students. Typically, since we have an alpha of 0.5, we choose a 95% confidence interval. And so it means that if you were many times to sample a group of first-year PhD students and to put them through this test and to get the mean, well then the confidence interval would contain 95% of these means. Obviously, you wouldn't always get 80, sometimes you would get 75, sometimes 100, but the confidence interval's 95% contains this mean. And if you do a test and you compare two means, etc., well, if the confidence interval crosses 0, it basically tells you that it's not significant, and the p-value in that case is usually above 0.05. Clear? Okay. So that was just about yesterday. Now, what are we going to talk about today? Just had one slide because we didn't finish yesterday with bootstrapping, and then we're going to dive into plotting. There's a lot to say. I'm sure I'm not going to get through everything because I told Amir that we would stop at the latest at 5, probably a bit earlier, so that you guys have time to do exercises. I mean, you know, but hands up. As a side note, this is a book which is quite old now, but it's really cool. I can also bring it if you guys are interested. It's basically about the fact that it's almost an art to represent data in graphs, and it's not enough to be able to type the code into Matlab. You also need to think, what do you want to represent and how. And depending on what type of research you do, it's really, really important. And it happens to me, and it happens to many other research, that I spend hours and hours, days, on just making one figure for an article because it's really important. And still afterwards I discover things which could be done better. So plotting is important because you need to convey quickly the essence of your data to, say, a reader of your articles. But before you dive into plotting, just quickly, what is bootstrapping? So the advantage is that it's a non-parametric way of analyzing the data. You don't have to have data which is normally distributed, like it is usually required for the t-test or the ANOVA. bootstrapping can be used to test many things, and here gives you just one example. So we want to see whether the correlation between two variables is significant. How are we going to do that? Well, I load raw data, and in there's two vectors. One is called set, and the other one GPA. You already know the function core, and I get a correlation value, which is very high. But is it high enough to say that they're significantly correlated? Well, oh, this is the graph, by the way. You can see they look quite linearly correlated. So now, okay, so each of these vectors has 15 elements. So now what we're going to do for 1,000 times, we're going to repeat the following procedure. We're going to go and say if here there's a pot called L set. We're going to take one element out and put it in a box. We put it back into it. We mix L set. We take another one out and put it in our box on the side. We do this 15 times until we created a vector out of random sampling of this L set with replacement. We do the same thing for GPA and we correlate them. We do this 1,000 times. Okay? What comes out? Well, this is the formula, by the way, how to do this. And we get that if you do 1,000 times this sort of random selection and correlation, you get a mean correlation of 0.76. And you also can get the confidence interval, which does not cross 0. So this suggests that the hypothesis is significant. And this was just an example. Bootstrapping can be used for many other tests. And you can use it, for example, as the equivalent of the t-test. But as far as I know, with bootstrapping, you always compare two things. So compared to Nova, that's a problem because with Nova you can look at interaction of different factors, or you can have one factor with many levels. And if you have to do bootstrapping for your work, well, use help bootstrap or whatever, and need to try to find out more about bootstrapping. Okay, now about graphing. Graphing is really cool in Matlab, and you can both do graphs by typing in the command window and by selecting variables in the workspace and using the graphical user interface. That's what I just said. There's different types of graphs, and the cool thing is that when you do a graph using the graphical user-friendly interface, then the commands, the actual commands, they're displayed in the command window. And it's good if you don't want to take that script and put it into your script and save it and modify it. So here I was telling you to do this, but maybe we don't have much time. But you can just, for example, right-click on a variable, say acceleration if you had loaded carbig, and hit plot, and you would get something like this. And if you want to do the same thing but using the command window, you would write plot acceleration, and the result should be identical. We can also do a scatter plot where we compare the correlation between two variables, and here I'm putting acceleration on the x and horsepower on the y-axis. Well, so if you do this in the graphical user interface, you need to select them both using Shift or Control. I don't know, it depends also whether you have Mac or Windows. And then same thing, you hit right-click, I think, and plot them as scatter plot. With Control and Command. So you get something like this, and then you can turn the axis. And in the newest Matlab version, I saw it's on the top left. There's a little thing with double arrow, and if you hit that, it should turn the axis. And okay, it looks very similar now, but you see that this has moved up. Okay, then there's a cool thing you can do. You can also plot in 3 dimensions. So for example, if you type scatter 3, acceleration, MPG, and cylinders, you get a three-dimensional thing which looks more or less like this. Here I also labeled the axis, and you can actually rotate that. So at the top of this figure, there's a little sign. If you hit it and then you click on the figure and move it, you can rotate it, and that can be very powerful to better see the data. How do you modify a graph using something which is called plot tools? Well, for example, let's do a scatter, and then so here you imagine the figure comes up. Then at the top right is a little symbol like this, and if you hit that, plot tools open up, and you can, for example, add a title, which should be very easy because once you have open plot tools, there's already written title. So plot tools looks more or less like that, and if you want to label the x-axis, if it doesn't come up immediately, you have to hit the x-axis, and then you see this label, and same thing, you can label the y-axis. And then the cool thing is that before you close these plot tools, you can actually go on File, Generate Code, and again it saves a script which has everything as code. Okay? Everything you did here is then saved as code. And then that's very useful if you want to integrate it in a script you're writing, so that you can do these figures over and over in an automatic way. Here I'm showing how to do a scatter plot by typing in your commands. Again, scatter, you choose two variables. You can add labels for the x-axis, for the y-axis, for the title, the legend. That's how you do it. And then maybe at some point you want to save this picture here, or this figure. And so one way to do it is to type print, and then you tell him which figure you want to save, figure 1, in which format, JPEG, and obviously there's many formats, and the name you want to give to it. And it's going to save it in the folder you're in your current working directory. So if you don't want it to be saved there, you need to add a path of a different folder. How can I put different plots one on top of each other? Yesterday somebody was asking this. Well, you use hold on. Previous versions that were also using Matlab using hold all, which still works, I think. For example, here I'm plotting first acceleration, and then on top of it, I'm plotting miles per gallon. And I don't remember, I think acceleration was blue, but I don't remember the order. Matlab chooses colors automatically when you do that. You can, however, also specify exactly which one is it going to be, which color, and how the lines are going to look, and even how the markers are going to look. So the lines that connect to different data points, and at each data point you can put a marker, which can be of different sizes and colors. So here, for example, I'm specifying that I want acceleration to be red and dashed, and I want the little squares as markers. And then I say hold on again. On top of it, I put the green line for miles per gallon, and the markers are round, but you can barely see it. And the line is continuous. If you type head plot, you can find that, for example, red is defined as R, black as K, magenta as M. And it's also different. There's other ways also of really telling the colors. These are just some handy shortcuts. Other shortcuts are for line types. I'm just giving you two here. This, for example, would be a dotted line. A dashed line would be with two hyphens. And a hyphen and a dot is the dash dot line.
Can we just modify these things in the editor directly? Like point and click?
You can also modify that directly. I will show that in a second, I think.
Okay.
You mean in the graphical user interface?
Yeah. I open it and double click and want the dash line.
Yeah, you can do that too.
Okay.
Yeah. This is if you want to type it as a code, but there's also a way to do it interactively with the GUI. And so these things, you can also combine them. So I can say I want a green line dashed with triangles as markers. And if you type dog color spec, you see our color types. For example, I said that yeah, this is an easy one. R stands for red, but in red, green, blue, it would be 1, 0, 0. Because maybe yesterday during the exercises you learned that colored pictures have like 3 layers, and the order of these layers is red, green, blue. You should remember. And so red is the first is 1, the other one is 0. Green, the second one is 1. Blue, the third one is 1. And white is all to 1, and black is all to 0. You can change other things like the limits of the axes, whether there's a grid around this amount, so that's the box, the grid are the lines actually. So you can really modify your figure in 1,000 ways. And I don't even know all of them, but you can find them out. So this is really important. Whenever you hit plot something in the command window, automatically a figure is created. And inside of that figure, there's something called axis. Inside of the axis, you have a graph object. Okay? So this is important because, oh, by the way, this was going back to what you said, Tiziano. If I had plotted something and I just use the pointer, I'm showing here, and then I click on the line, then this happens. Then actually double clicking opens up again this plot tools which I showed you before, and then you can modify them all ways. Blah blah blah. Okay. So these things about figure and axis, they become important if you want to change them typing code. Okay. So the way you access them is with this kind of writing get, and then the name of the handle, they're called handles, and then the property, say color, or line style, and so. And the way you change them is using set. Okay? So, oops. Yeah, the handle is a special number which refers to graphical entity, and each figure, axis, etc., they have a handle. For example, for figures, it's just the number of the figure. Figure 1 is going to have 1 as the handle. So if I say set 1, color green, what happens is that the background of my figure becomes green. If I want to verify that it became green, I say get 1 color, and it gives me 0, 1, 0. But if you know the order is red, green, blue, so this is everything to 0 but the green. And again, I can change it back to white, so say set 1 color W, and now in RGB would be 111. Okay, if you want to know which figure you're working on, or which axis, which object, then you type GCF, GCA, or GCO. And if you say have 2 figures open, you click on figure 1, well then your current figure is going to be 1. If you then click on figure 2, your current figure is going to be 2. So keep that in mind, because if you interact with the figures, the handles change. So if you open a new figure and then say get current figure, you get all the information about the figure. You can automatically save that information into a variable, which here I call Matlab1. So I plot something but save the handle in Matlab1. And this is the kind of information you get, a long list about color and marker and marker size and all kinds of things which you obviously, if you get this information, it means you can also modify them. this is an example. So here I would change the line width. Since I had saved information of the figure handle in my plot, now I'm going to say set my plot line width 2. Then I want to see which color it is. Well, it's still green. Then I'm going to change the color to cyan. And now the color, the line color has changed. I can change the position of the graph using the variable, the indicator position. And it gives me 4 numbers, which mean, so the left and bottom elements define a distance from the lower left corner of the container and the lower left corner of the axis. So, you know, if this is your container, and inside of it you have the axis, would be the distance between the lower left corner of the axis and of the container. And then you have the width and height of your axis. And that's the way you would change it. Okay. It should work out that the examples I gave on the slides before, you know, they give you a figure, and then if you change the position, you know, it moves to this upper left of the container. There's a ton of different graphs you can do in Matlab. And one handy one is bar graph. Very easy to do. If you have a matrix with 3 columns, you just use bar in the name of the matrix. Really more important is to plot something with the error bar. For example, here I'm loading exam grades, so I think we already worked with this the other day. There's like 120 lines and 5 columns. Let's say, for example, these are 120 students in 5 different schools. If you type error bar and you want to plot the mean of each column, remember that when I give a function like mean, per default it goes down each column, right? So mean of grades is going to give me 5 numbers, because I have 5 columns in grades. And SCD stands not for disease, but for standard deviation. And again, I'm going to get 5 numbers, which is the standard deviation of each column. So if I do this, I should get this plot, which is each mean with standard deviation. And it doesn't tell much. Oh, this is just to put the numbers 1 to 5 here, and then we put the title. But it's much better if you use the standard error instead of the standard deviation. The standard error is the standard deviation divided by the square root of n. And when you do that, and here is how I did it, I get a graph which is very different. Okay? Because so here I define actually the limits of the y-axis to have them the same, to have them comparable, and just to show you that the standard error is much smaller than the standard deviation. They're both measures of the dispersion of the spread of your data. Useless to say that this looks better on your graph than this most of the time. Okay, and how do we inspect correlations? There is, for example, this function called plot matrix, which gives you something like this. And so it's very visible for you, I know. But here, this is similar to what we saw yesterday. Here you have 5 columns or 5 variables, their distribution, and then they're each correlated with each other. And you get a cloud of data in the scatter plot. And whenever it looks kind of like it could be correlated, well, let's compare this, for example, with the calculations. This is visual, this is statistics. If I take the second and the 5th column of ratings, that corresponds to this, right? And the correlation is 0.35, and the p-value is highly significant. So it seems significant. But much cooler is core plot. I showed you yesterday, I think. The way it works is like this. There's a very cool feature also. So first of all, you can specify if you want Pearson or Spearman. And second, you can tell him with this test R on to basically flash in red the correlations which are significant at P05. So that would be the same stuff, but looks much better, and it does a regression line and it tells in red which one is significant. This is the one we looked at before, and this is what we had computed before. And here's 0.35, this is 0.35, so it works and it's the same. This is very nice, however, it didn't work for some people yesterday, right? Over there. You couldn't have, you didn't.
Now it's working.
Now it's working. What did you do?
I reinstalled it.
Ah, okay, so apparently when you installed Matlab, you unchecked some. That might also be the reason maybe why some of the data is not available for some of you.
No, because I installed all things when I installed. I
Installed
stripped all,
yeah.
but I didn't have the pictures.
Okay. Oh, but that picture I didn't have either, actually. Good. So, another thing which is great is subplot. So before I told you, you can plot two things one on top of the other using hold on. But that can be confusing sometimes, okay? Because obviously they can have different scales or they can superimpose each other. Sometimes you want to have stuff close to each other but not on top of each other. And subplot helps you to do that. So you give three parameters to subplot. The first one is the number of rows. The second one is the number of columns you want. And the third one is just which of these subplots I've created do I want to access, to write into it. So here, for example, I would put 2 for n, 2 rows, and 1 for n, because it's just one column. Then if I want to start writing in here, plotting my data, p would be 1. Then I move to here, so p becomes 2. That's explained here. The first subplot 2, 1, 1. I do my scatter, give it a title. Then subplot 2, 1, 2. I think this hold on is not necessary. Subplot 2, 1, 2, and again scatter title. Okay. Actually, I went much faster than I expected. Any questions so far? No?
So subplot doesn't go in a vector, in a column major order, 1, 2, 3, 4.
Yeah, it goes in a weird order. So, I do it here so it's visible for everybody. This is my figure. If I do something with 3 columns and 3 rows, and I want to plot in here, it would be subplot 3, 3, 1. And if I want to plot in here, it's 3, 3, 2, 3, 3, 3, and then it goes here. 3, 3, 4, 5, 6, 7, 8, 9.
So it acts differently than Matlab.
Exactly. So this is like if you were, for example, reading a book in English or whatever, not Arabic. You start on the left, you read the first line, then you go down, start on the left, read the second line. Okay? Yeah, I don't know why they do it like this. Okay, so since Ani is not here, I'm going to say something about file input and output. Obviously, data can come in many ways. It's best if you can just save the data as .mat, or as I often do this, tab it into text files, because that works actually with everything. You can also open it in Excel. So for example, you could save into a file called data.txt your data as ASCII tab delimited. What is ASCII? Well, it's just a format. And okay, this is just some story, you don't need that. So if you now have some data, in data.text, and you want to load it, you can say, I put it into x, so x equals load, in parentheses, data.text. However, this only works if it's all data, it's all numbers. Already if there's any header, that can create problems, because you cannot read it. This is an example of data. There's other formats, and you can get a list of them, typing help, IO For example, I just wrote you down here some which are important. DRM read to read SQL to files. DRM write to write them. CSV, well, it's comma separated. Sometimes if you use Excel, you can save it as CSV. This is obviously Excel is read, Excel is write. On Mac, they work, but with problems. Very powerful is import data, if you know how to use it, which can handle basically all types of data. And to save data, for example, as a text file, I use f. Okay, I didn't tell you much about these formats, but let's see some examples. So I load gas and create a new variable where I concatenate price 1 and price 2, and then I save it. So these are just numbers, so I can use DRM write. I give the name of the file I want to save it in, and the variable I want to save, which is new gas, and how I want to delimit these two columns, because there are two columns of data. So if it were, for example, CSV, the limiter would be a comma. So it would be 118, 128. Yeah? But now I want a tag. So that's how I would do it.
Is it specified the limiter, like word limiter?
Which limiter?
The limiter.
Yeah. What can you?
In order to tell the program that you want it to be separated by a tag, in this case,
you have to say
before the actual t/t, you have to write the limiter.
Yeah. You have to write the limiter. I mean, I can give you the answer for sure afterwards, but I would say yes. And to read in that data, I would just use DRM read. So this is kind of easy. However, then if I want to save it with fprintf, well, it's a little bit more complicated. But it has some advantages, because you can, with fprintf, you can save text files very in a neat way. So I'm not going to go into details now, but you need to transform it into strings, and then you need to do an fopen, and then you do a loop, so you have strings separated by tab, and at the end, at the last column, there's an end for going to the next line, and then you do an f close. Okay. So we talked a lot about numbers, but we haven't talked a lot about characters and strings. And if you use a single quote, that's how you tell Matlab that you're actually giving him a character or a string. So one letter is a character, and a series of letters will be a string. Spaces also are part of the string if they're contained in the quote. Also in the command window, they're shown in another color. So if you type strings into a command window, they are, I don't know, dark red or violet, depends on how you put your color. And if you want to write something in the string which contains a quote or an apostrophe, well, you need to double it. So if I want to write "it's cool,"